Greetings again and welcome to energytech.co.uk. In this particular video segment, I'll be sharing how you go about calculating the appropriate solar array size for you. Now, this video is to just talk through a calculation that we've already posted on the website, so you should be able to see the detail. If you go on the website, go to the blog, and one of the blogs is the one that I'll be basically browsing through today and just talking over, because we're just aware that people take information in different ways, and sometimes just hearing somebody describe something brings more to life what's been written down on a page. So why might you want to do this, and who might be the appropriate audience for this particular video? It's basically people who perhaps for the first time are thinking of turning to solar and really don't know where to start and want to understand for themselves before they go out to anybody else there, because there are two main routes that people use. The first one is this one, i.e. work it out yourself from first principles and determine exactly what you need and how you size it. And the second route, which I think more people go down, is invite a number of companies to come and quote for you, and then just start to gather your understanding of things based on those quotes and based on that information that comes through. Now, I'm not a big fan of that second option, i.e. just going out for quotes and going on purely on recommendations, because when somebody else is doing these calculations for you, they're already making some choices for you, some choices that perhaps if you knew the detail, you might not do that thing that they're suggesting that they're gonna do, because sometimes it's because it's easier for them, and sometimes it's because they don't really understand how you want to operate, and sometimes it even comes down to budget and cost as well. So to just use a simple example for the latter, if you were to go with a certain company because your friend, your neighbor simply recommended them as a good company to use to install something for you, there are multiple issues that you might then incur and penalties you might incur as a result of that. Number one, from a cost perspective, if your neighbor or your friend has got a higher disposable income than you, their choice to go with that supplier may well be just predicated on the fact that actually they did a good tidy job, right? Which is fair enough. However, it may not be linked to price necessarily, or at least their perception of price might be very different to your own. So just on the basis of that example alone, I think it's worth doing your own calculations, and then that way you're quite clear in yourself that you're getting what you want and what you need. Anyway, enough of that. Let's get into the calculation itself. Right. So the important thing to highlight is, once you've got your bill in front of you, ultimately we are trying to determine an output in kilowatt hours per year that a solar system would generate for you. Right. So the calculation, there's basically an equation we're trying to fulfill, and that equation is somewhere on this page, is this one. It's the estimated annual output in kilowatt hours per year, which is given by array size multiplied by the solar radiation input factor multiplied by the shade factor. So number one is understand what your energy usage is, right? Because once you know what that is, you know at least what the minimum number you're trying to hit with the system that you're designing. Then the second step is so that first step is usually as simple as looking at your bill, because energy companies are required to put on there either your actual usage for the year gone by, or the estimated annual usage based on the current consumption data that they hold for you. So that's the first place that's easiest to start. Just look on your bill and understand and look for the section that tells you how many kilowatt hours per year your company is expecting you to use, right? Then the next step is to now estimate how many panels you can potentially fit on your roof. Now, I say roof, it might be that it's the garage roof that you're planning to use, or it might be your actual house roof, or if you're planning to mount them on the ground, it might be just the area that you're looking to set this aside for. But I'll refer to this as roof at the moment because typically that's what we're talking about for at least, simple people like myself who are, who the only space that they can really use for this is their roof. So I'm going to describe it as roof, but apply it to your own situation or whatever it is that you're considering to install solar panels. So the first thing to be aware of is the standard panel size that you're probably going to be looking at for this type of installation is 1.7 square meters, i.e. a panel is about 1 meter long multiplied by 1.7 meters wide, right? Depending on what orientation you're going for. So that's the area of a panel. So then you want to calculate the area of your roof space and divide that by the area of a panel, and then that will tell you the most number of panels you can fit. So in this particular example, I've calculated that your roof is 45 square meters. So if you divide that by 1.7 square meters, it gives you 26.7, which means 26 is the most panels you can fit onto a roof area of that size, right? So that's the first bit, because now we know how many panels we can fit on there as a maximum, right? Now, knowing that figure, you can then now calculate the the various array sizes you can fit onto for your roof. And what that means is looking at panel output. So you can go for a 305 watt output panel, multiply that by 26, it gives you the array size in kilowatts peak. So KWP. So the P is for peak. That means for that system, that's the maximum amount that system could generate under perfect conditions. So the example I use in this case are, imagine you've got 26 panels and each of those panels outputs 330 watts. So which means the array size would be 8.58 kilowatts peak. And I've also used a second one, which is again with 26 panels, but if you go for a set with an output of 370 watts per panel, the size of that array would then be 9.62. So which means the individual panel output and the number of panels, those are your variants. You can either go for a high panel output, which will more likely cost you more because each panel is able to generate more, or you can conversely tweak the number of panels you've got. So you could buy the cheaper 330 watt output panels, but have more of those to achieve the same number, or so you get the drift. So that's the point of that first bit in terms of calculating the array size. So work out for a range of array sizes and determine what you want from that. And in terms of what sizes you can go for, if you go on websites like Midsummer Wholesale, for example, you can look at different panels and get a bit of an idea of the output you get and also the cost side of things. So you can start to factor in the cost at this point. But just be aware that this cost does not include the actual installation of these panels. So if you were to then go to a supplier to say, well, this is exactly the panel I want, and can you quote this for me? They'll obviously look at that, and they'll also add their installation fee on top. But at least it can start to get you some way along the thinking of potentially what this might cost you. And also bear in mind the other potential saving is if you go to a supplier who does an installer who does a lot of these, they may well have bought these in bulk and therefore acquire them for a lower price than you might get from sites like Midsummer Wholesale if you went there direct yourself. So just some factors to take into account there, right? So now the step we've just done there is calculate the array size. So panel output in watts multiplied by the number of panels. The next step is to calculate the solar radiation input factor, abbreviated by the KK abbreviation. And what that is, it's basically a combination of a number of variables to give you that figure. And those variables are the azimuth, which is the direction that your roof faces. So if your roof faces south, then the azimuth is 0 degrees. If you're facing west, it means that figure is 90 degrees. Instead, if you're facing east, because you're reversing from south, it means it's minus 90 degrees. And so using those points, you can work out, if your roof is facing anywhere in between those, you can work out what your azimuth is, because it's basically that degree variation. So for the purposes of this, just use your phone, your iPhone, or compass that you've got in the drawer somewhere to work out what that direction is. The next variable here is the pitch. Now you will need to calculate what the pitch of your roof is, i.e. the angle from the horizontal. The sweet spot is usually anywhere between 30 and 40 degrees for the UK, that is. So if you don't already have a detail of this somewhere, so for example, if you live in a recently built new home, you might well have the plans that tell you exactly what that is. Or you can, if you don't know, do a bit of a calculation to work it out. So a bit of trigonometry, a bit of Pythagoras will get you there. I'll try and do another quick short video to explain how to do so. So, but if you're doing this right now and you just have no clue what it is, use 35 degrees as a bit of an approximation until you can do a better calculation later on. Then the final one is to also calculate which zone in the UK you are, because as you move from south towards north, the amount of solar radiation each part of the country gets, is getting less and less, the further you go up north. So each bit of the country, in fact the world, has people have done some amazing work really to do these calculations that tell you the irradiance that each square meter, square mile of the earth receives. So you can actually start to become pretty accurate with working out how much you might be what you expect to generate given any part of the country or the world that you're in. Now to do this, there's a chart which simplifies how you can assess this, and I've linked to this chart. So and it's all this data is coming from the MCS website, by the way. So if you live in Cambridge, you'd go on the chart and pick up number 12. If you live in Birmingham, you're number 6. If you live up in Edinburgh, you're in this pocket here, which is 15. So once you know which pocket you're in, the next thing you want to do is go onto the MCS website and download this chart, which is basically the solar irradiance dataset that they've published on there. And so using that dataset, you can then now work out what the bit you live in, what that number is, that solar radiation input factor. And what you do is across the top, you can see that that's the orientation from the south. So if your house was facing southwest, you'd be at 45. And if the pitch of your roof was 35 degrees, you're then looking for the intersection of those two. And in this case, it is 883. I can just about make out what it is. And so just to recap, you've calculated the zone that you're in. You go to that to the data set, download that. Is basically a spreadsheet, and then you look for the tab that corresponds to your area. Then for that, you can then ignore every other tab in there. Then you now want to look for the orientation that corresponds to yours for your house, and then the pitch of the roof. And where those intersect, that's the number you want to take out of that. So once you've got that number, the next thing you want to do is plug, we're gonna hold that number and we're gonna plug it into our equation here. So we already know what the array size is. We've just calculated what the in this fourth step what the solar radiation input factor is. So you plug that in there, and then the final variable is the shade factor. Now, if you've got no shade at all on your roof, the shade factor is 1. If your roof is 100% under shade, then the shade factor is 0. And if you've got a shade factor of 0, your system is not going to generate anything, because you're pretty much saying your system does not get any sun at all. So the perfect is 1, and as that decreases, the worse your system performance is. I'll do a video that looks at how you calculate the shade factor, but ideally you've got no shade at all from chimneys, from I don't know, any other features you might have on the roof, like satellite dishes and trees and things like that, right? So then once you've got that, it's then a straight up calculation right across to work out your output per year. Your estimated output per year, I should say, based on the data for your area. And in this particular example, that 8.58 kilowatts peak system would have an estimated output of 7,576 kilowatt hours per year. And the corresponding calculation for the second array, which was 9.62 kilowatts peak, is this 8,494. Now, once you've done this calculation, if you've done it in a spreadsheet, you can then vary the size of your array to see what changes you can make here. And as I say, you can also vary it by either changing the number of panels or changing the output per panel. And if you're also looking at the costs, you can start to strike your own understanding of what's the best price point you're aiming for and size of system. This is the standard calculation that an MCS accredited supplier is required to be able to provide you. If they use a different method, they are required by the MCS standard to inform you of this. So basically what I'm saying is, if you do this calculation this way, you should be able to tie this in with any quotes that anybody gives you, and also any information that they give you. If they tell you any different, you can start to challenge that a bit more. And as I say, I think that's the more informed way of trying to work out the size of a panel. So please go through this page and use that to inform what you need. And if you've got any questions, as others have already done, I'm happy to share more detail, clarify, and in some cases, correct, typos or mistakes that I've made, or link to more up-to-date information. So hopefully that was helpful, just talking through it in that manner. And best of luck, and speak soon. Bye for now.